After nearly 2 years, the GSEO interviews are finally back. When we first started this series, our goal was simple: to give students around the world access to honest conversations with exceptional people, beyond polished achievements and into the stories, setbacks, and ideas that shape them. We're excited to restart the series with Thang Pang Ern, a pure mathematics undergraduate at the National University of Singapore, whose work spans analytic number theory, undergraduate research, teaching, leadership, and even contribution to the OEIS, which is the Online Encyclopedia of Integer Sequences. Whether you're passionate about mathematics, considering research, preparing for university, or simply curious about how top students think, we hope this conversation will leave you inspired. Welcome, Thang Ern. Would you like to introduce yourself to the viewers?
So, hi everyone, my name is Thang Pang Ern, and currently I'm a second year, I just finished second year at the National University of Singapore, and currently I'm studying pure mathematics. And in the coming semester, which is the fall semester, I will be an exchange student at the Polytechnic Fédéral Lausanne, and that is EPFL in Switzerland. So I'm looking forward to the life over there. So currently in undergrad, I've done a lot of things as what Karthik mentioned. So thanks for the introduction.
Okay, perfect. It's amazing how you're gonna be a exchange student as well. So you're studying maths primarily, right? What made you fall in love with pure maths, and when did you realize that it's something which I want to pursue, even in uni and ahead?
So firstly, pure math is something that I thought that maybe it is something that I can pursue in the long run. But I realized that maybe whether I want to do pure math after university, it has somewhat become a question mark. So I'll come to that later. The first thing that I would like to discuss is how I got so involved in this. And that is perhaps started out when I was, let's say, about 9 or 10 years old. So when I was 9 or 10 years old, usually, like every other kid, right, I would go play computer games like Minecraft, GTA. Back then, I think GTA 5 came out already, so 2013. But I was more into like GTA 3 and 4. I didn't really play 5 when I was a young kid. So yeah, just like any other kid, I played games and I had a lot of fun doing this. But on top of this, I also, on top of my gaming addiction, I actually had a huge love for math. And that is because the math that you do in school, it's, I think, out of the 4 subjects that you do, right? So back then I would do English, mathematics, science, and Chinese. And then I realized that, math is sort of the only subject, and maybe maybe science as well, but my science was horrible back in primary school. So math is the only subject where getting 100 marks is possible, because it's just like working with numbers, and you don't really have to make use of that much critical thinking back then. Okay, so yeah, and I was so intrigued by a lot of the things that my teacher told me in math. So that prompted me to, sometimes I would just go onto Wikipedia to look at random articles, and I would completely not understand them at all. Although back then, when I was like 8 or 9 years old, I actually knew what the sigma notation is, so the summation notation, and I knew pi when I was 8 years old. I knew the Basel problem. So the Basel problem is basically the sum of the reciprocals of the square number. So that is 1 plus 1 over 4 plus 1 over 9 plus 1 over 16 and so on. Yeah, so this gives you pi squared over 6. And I just knew this random fact when I was 8 years old. The other one is Leibniz, or rather 8 or 9 years old. The other one was Leibniz formula for pi. That is the alternating sum of the reciprocals of odd numbers. So 1 minus a third plus 1 over 5 minus 1 over 7 and so on. This gives you pi over 4. Yeah, so I knew this kind of thing when I was very, very young. And yeah, so I was so interested in pi and just math in general. I would look up Wikipedia, just look at random articles. I remember that even though I knew the summation notation, I actually was quite scared of the integral notation. So the integral symbol was something I encountered long ago. It's just that I saw this S hook kind of thing, and it scared me away. So I was like, oh wait, so you do all this crazy kind of thing in math eventually. I saw all these kinds of things, and I was thinking that, if what I'm doing in primary school is working with purely just numbers, and so in Singapore we have this thing called the model method for solving problems, right?
Right.
So if my whole life I just deal with solving problems like and counting, let's say, to 10 million, things like that, rather than dealing with all these abstract concepts, then I really want to wonder, oh, so that is the real math, right? So
Yeah.
whatever I see on Wikipedia, that is the crazy stuff out there that perhaps people in the modern days are doing. So I guess that's one kind of motivation I had to learning it. And also there was some websites where I got to learn a lot of interesting math stuff. So, like, for instance, there's this website called Math is Fun. So yeah,
Okay.
literally Math is Fun. And they had a lot of math games and random math articles which were more suitable for the general elementary school student like myself back then. So that was one other avenue. And also the other thing is that there was this YouTube channel called Number File, and it still exists
Yeah,
today. In fact, I met one of the like co-founders of the channel. His name is Matt Parker. Yeah, so he came to Singapore quite recently. I think it's like maybe like a month ago or something like that. So yeah, we went to somewhere in the city area of Singapore. So he gave a talk, and it was really interesting. And I mean, I didn't know him as the guy who I didn't know that he gives talks nowadays, and he has this YouTube channel, something like Stand Up Math or something like that. I didn't know him as this kind of person. Back then, when he did Number File with a bunch of other people, I knew him as the guy who made math more accessible. So back then, I would just watch all these YouTube videos where, you know, there are some videos, right? I guess even you might have heard of the alternating sum. So 1 minus 1 plus 1 minus 1 and so on. That's equal to 1 over 2 half, right? And there's this crazy infinite series, 1 plus 2 plus 3 plus 4, and and you go on forever, right? You get negative 1 over 12.
Yeah.
Or negative 1 over 12. Yeah, so it's something by Ramanujan, and it's related to the analytic continuation of the Riemann zeta function. So yeah, I mean, as you can tell, right, based on our conversation so far, I'm really interested in I was really interested in infinite series back then. And yeah, I watched Number File videos. It was so good because they explain things that sometimes I would learn in high school or maybe at the university level. They would explain it to the average viewer that you see in the world. It's really cool. And so that was when I was young, and then I progressed further to secondary school and then junior college. So junior college is like high school, the American equivalent. So I had good teachers, like really good math teachers when I was in junior college, and they would, and you know, like the Singapore A levels, when we do mathematics, right? So there's the normal level of mathematics that I guess every student takes it, and it's so simple. Like even when you do the school examination papers, right? It's actually so simple that I realized that, well, whatever my teachers introduce in class, they teach things outside the curriculum, outside the textbook, and they make math so interesting. And that's where I realized that, oh, my primary school self is coming back, where I'm getting way interested in these kinds of abstract ideas again. And eventually it made me decide to pursue a major in pure mathematics at the university level. And if you're wondering why pure mathematics, because math is so broad, right? You can graduate as with just a math degree with no specialization, or perhaps you could get a specialization in the current thing is we have one which is pure mathematics, and we have data science, and I think it's like operations research and data
modeling.
analytics. So, modeling, those sort of things. So those are the broad areas, right? Or you could just get out of uni without the specialization. Then why did I want a specialization in pure mathematics? It's because I realized that the rigor of pure math, it's something you can't get from anywhere else. And I realized that it's about learning the rigor of pure mathematics that makes me so, like, it keeps me awake. So every time I wake up, I realize that, you know, there's some unfinished business I need to do, and I really need to get into the weeds of it and try to figure out what's going on and so on, right? But then a lot of times, you face some setbacks because certain things are really too difficult for you. Yeah.
Wow. So it started all the way from, back in primary school. It's a long history then.
Yeah, so from primary school, that is like 2011, 2012, that kind of period.
Okay, so quite some time back. Have you ever been a participant in any math competitions or Olympiads?
So for math competitions, well, there's a lot to count, but
Uh-huh.
I think I'll just talk about some of the interesting experiences. So let's go back to primary school again. So 2012, so that was when I was primary three, and then I received so if you do well in mathematics in class, right, then naturally your teacher will tell you that, oh, hey, there's this competition out there. So it was
Yeah.
called the NMOS. So NMOS is the
Oh,
National Mathematical Olympiad of Singapore. So those 3 years you would spend time. So 3 years as in 2012, 13, and 14. Yeah, I would spend time practicing for the competition. So what happens is that there's this external vendor that would come to our class. So there's only a selected bunch of people in our class, right? I think it's like half of the students. So half
yeah.
is like slightly less than 20 students, I think. And back then we would stay back after a certain day, and every week we would just the instructor would just practice on different questions. So like I mean I think it's like mainly working with those kind of like brain teasers, puzzles kind of thing, and
Yeah,
also
yeah.
working with number patterns and series. So
Right.
yeah, back then I was interested in number patterns and series, right? I was really really interested in them. So I guess that was one of the motivating factors for me to really read up a lot of these Olympiad concepts. And
Mm.
yeah, I still remember some of the questions and like even how the book looks like till today. So that was the NMOS. And then if you fast forward to 2014, so that was when we actually sat for the competition. And I can't remember when we sat for the first round of the contest. That was okay. I mean, I really can't remember when, but what I knew of was that later on I got informed that they selected about the top 10% of the students around Singapore, right, to participate in the second round. And I remember that the second round only has about 146 students. So if you do the math, probably like how many people went into the first round is about 1,500 people. So,
Mm.
and I was one of the 146 to be selected into the second round. So
Wow.
that was quite crazy because back then I didn't really care about getting any award. I just did things for the love of math. Yeah. So like if you really love something and you just keep pursuing it and just go on and on and on, right? Yeah. You can't stop. It's like a train that has gone out of control. Yeah. You can't stop and you just keep continuing this kind of thing. I really really loved it. I didn't expect to get into the second round. Even though I knew that I probably did somewhat well in the first round. Yeah, I just didn't really care about getting into the second round. Because my teacher actually mentioned that if you take part in this competition, it's really for exposure. You just,
Mm.
um, yeah, you just see what kind of questions they can ask, and the kinds of questions that they ask in Olympic competition. I mean, all these Olympic contests, they are
Mhm.
somewhat different from what you would see in your national exams. So in Singapore, right, at the end of our 6 years of primary school education, we sit for this national exam called the Primary School
Yeah.
Leaving Examination. Yeah,
Yeah.
so it's called PSLE, and the questions are so different. I mean, there's some similarities, right? But there's so many other things that are different from PSLE math. So
Mm.
it gives us some exposure to what kind of things there are out there in math that you are probably not exposed to in school if you are living the ordinary life.
Mm.
So that was what I felt. Yeah, so I went into the second round of the contest, and I remember that the second round was on 26 July 2014. So that's a Saturday. And you
Okay.
might be wondering how I remember all these kinds of how I remember all these kinds of random
Yeah.
dates, right? 26 July is because I remember that we had this thing called the National Education Show. So
Okay.
National Education Show just means that so firstly Singapore's birthday, it's 9th of
Oh,
August every year.
okay.
So 2014 was when we celebrated 49 years of independence. And so if you realize the difference, right? 26 July and 9th of August is not that far. So
Mm.
so every Saturday, right? There'll be some up to 9th of August. There will be rehearsals at this place in the city area, right? Where you get to see like the army tanks, all the troops and fighter jets, and then eventually a fireworks, right? So there'll be a lot of celebration for that. So I remember that 26th July, what happened was that I went to the competition venue first, then I went home, then after that I went to my primary school, and then so from my primary school we took a bus down to the city area where we enjoyed the performance. So that was really, it was really a long day because I had so many things going on. So that was for the second round of the competition. So and I realized that the second round of the competition, a lot of the questions were pretty difficult, and I didn't really do any preparation because I was thinking like, well, if I just go in with my current ability and let's just see how it goes. So I didn't really care about anything, but mainly about exposure. So I guess that's it. And then secondary school, there were some competitions like SMO. So SMO is the Singapore Math Olympiad, and my life there wasn't really interesting because secondary school I was dealing with a lot of things, a lot of the academic subjects. So sad to say, I really didn't have that much time to deal with math. Needless to say, Olympiad, right? But I still got some awards here and there, so like bronze and silver. And in secondary 2, so that was 2017, I took part in another competition. There's something called the Australian Math Competition. So so how it works is that I feel that for this competition, right, it caught me off guard because I didn't look up any past year papers, nor did I receive them. So I didn't really care how it was. So I just, you just go in without preparing anything. And I remember that the whole competition, you had 30 questions, and then it just arranges. The questions are arranged in order of difficulty, and the order of difficulty is really insane. And I remember that also you have not much time to work with these questions. Okay, or maybe like sufficient time, but not too long. So 30 questions, right? The last 5 were open-ended, and they just get in increasing order of difficulty. I mean, increasing order of difficulty is only, like, how I knew about this was only when I sat down and I flipped through the questions that I realized. So I remember like the first question, like they ask you, what is 2000 plus 500 plus 16 plus 8, something like this. And like you think it's so simple, right? But then as the questions get, as you go on and on, then they get increasingly harder. So I was like, initially I was spending a lot of time on the early questions that, I was like doing them maybe 2 or 3 times just to ensure that I'll get them correct. Then for the later part of the questions, I didn't really have that much time. And usually this kind of like the last 5 questions, right, where it's sometimes interesting, it's sad to say that I never get the chance to look at them because I ran out of time. But then having said that, right, I still got a really nice result for this Australian math competition. It's really a lot of things that went on. When I went on to junior college, so that was 2020 to 2021, a lot of things happened as well, and that was when COVID struck. And I still participated in the usual math competitions, right? But because like how my junior college life was like, I actually had a lot of time to spend on mathematics. Literally because out of the 6 subjects that I took for A level, 3 of them were mathematics related, or rather they were mathematics. Actually. So I invested a lot of time into mathematics, right? And I really, really enjoyed it. Spending time on Olympiad and also some research projects with my friend as part of a competition. And I even participated in this other thing called the Euclid, I think it's like Euclid Math Contest. Yeah, there was such a thing back then. The style was somewhat similar to the Australian Math Contest, but the difference is that the Euclid Math Contest, it had proofs. So I somewhat looked forward to that kind of thing. And other than Euclid Math Contest, I also took part in this other new thing, which is called the American Math Competition, so AMC. And so AMC is, based on what I knew back then, it's this competition where, so the starting round you have, the starting round you have 25 questions, and they're all MCQ, multiple choice questions. I think that each of the questions you have 5 options, A, B, C, D, E. And again, the questions get increasingly harder as you go on. You have 75 minutes to do 25 questions. So on average, you should spend about 3 minutes, right? But then it's not really evenly distributed because the early questions are pretty simple. But I remember that, and also if you get a question, like if like you don't answer a question, you get some number of points, but if you get it wrong, you get fewer points, and if you get it correct, you get the most number of points. And I forgot what's the distribution like already, but I remember back then, I heard about the competition, right? And apparently how it works is in the United States, all the students there, they sit for, I can either go to this contest called Math Counts, or maybe you do this competition called AMC. And then if you do well at AMC, then you take the top, I don't know how many percent of students, right? And then they get onto the AIME. So the AIME is the American Invitational Mathematics Examination. So that's where they select probably, I guess, maybe the tens of thousands, like 10,000-ish kind of people, I don't know. Then eventually they make it to the USA Math Olympiad, so USAMO. And then they have team selection tests and things like that. After that, they eventually narrow it down to about, they narrow it down to the final 6 students to send them off to the International Math Olympiad. So I guess that's how the selection works in the US. But yeah, I think if I actually had gone to the US, I would be at a total disadvantage because I find my flaws in the AMC, because AMC to me is like, I don't see the point of doing questions so fast, and like sometimes you won't even have the chance to read question maybe 15 onwards. Like probably that's what happened to me. And I didn't really get a good score in the end for AMC because I feel that it deals with a lot of like I actually don't know what's the actual technique for this contest. Unlike other contests, right? I feel that to me AMC was just pretty strange. I didn't really enjoy the experience though, in comparison to the other contests. But yeah, I mean, at least I got to see this in person and try it and really see that, there are people who get close to perfect scores or even perfect scores, right, in the US, and some of them, they eventually made it to the IMO and get silver or gold. But I actually have no idea how people even do it, how they even attempt questions this quickly. Yeah. And then when I was serving my national service, so there were times where I'll just look up random contests, right? Because after high school, like after IMO, that kind of period, you generally don't have contests that cater to the university students, unless you talk about something like Integration B or Putnam, or Putnam is in the US and Canada, I think. And for the non-American countries, right? So in the eastern side, as well as I think Europe, we have this thing called the Simon Mary's Mathematics Competition. It's called SMMC, and the style is somewhat similar to Putnam. And I think the opportunities available to university students to participate in competitions, it's definitely lower. Yeah. So when I was serving my national service and currently in university, right? Yeah, I took part in this thing called the Instagram. Okay, back then it was called the Instagram Math Olympiad, IGMO, but the new IGMO, they call it International Gamma Math Olympiad. I took part in that. I took part in another thing called I think it's like some calculus contest online. I got 6th place out of 200 plus people back then. For the IGMO, I did pretty well as well. But again, all these are online and they are monitored. So that is for that case. And I also took part in this thing called the IYMC. And IYMC is somewhat recent, I think. So IYMC is called the International Youth Math Challenge. So I think it started in 2018 or 2019, I can't remember exactly. But I kind of like some of the questions over there. They are quite interesting. And there's a section where they ask you to analyze a paper, and then they give you some open-ended questions, right? Yeah, so I enjoyed that. And when I went on to university, that's where I took part in like this one and only competition available to uni students, right? And that is the SMMC, that like what I told you just now. So yeah, I mean I enjoyed it, and I also took part in Integration B. Yeah, so contest wise, Olympiads and contests, right? They span over my whole mathematical life. So from primary school all the way up to now. Yeah, really a lot of things have happened.
Wow, so quite a long history. And I can relate to you in that sense. I also used to participate in math competitions since P1. So from P1 all the way up to the JC1 was my last competition, and in fact it was the IYMC as well. I looked at your profile. I was looking at what all you did, because I'm also a math lover. So I was looking at
Okay.
how to participate in many competitions. I joined IYMC, and I actually ended up getting the first rank in Indonesia in the final round. So it was a pretty big, yeah.
Do you remember how many points you scored?
I think it was 24 or 25, somewhere around that range.
Oh, out of 30, right? I think I didn't do that well for the previous iteration. I got 25 out of 30. But then 25 out of 30 in Singapore, right? You don't come close to getting third prize. So
Right.
yeah, unfortunate.
But it's excellent. You have such a long history of joining math competitions. And until JC, looking back, would there be anything that you would change in the way that mathematics is taught in school?
Okay, look, I need some time for this. How mathematics would be like?
Yeah,
what would I change?
Yeah, what would you change? Because nowadays a lot of students, when they think about maths, they immediately become scared. It's a lot of numbers, a lot of calculation. Is it a way that the students are taught? Is it something about the content? Is it the way that they're exposed to the questions, more to memorizing formulas rather than understanding why they're actually used, how they're derived? What do you think would be the number one thing you would change if you could get the chance?
Okay, well, firstly, right, I think maybe it's applicable to the secondary school context, I guess. So, what students would learn is, if let's say you practice a lot of questions in secondary school math, I feel that for that case, right, if let's say you do that and you apply it to when you go on to doing your O-levels, right, O-level math or additional mathematics, the good thing is that, well, the techniques are all pretty much the same. As in, there's only that certain types of questions, right, that that they would ask you, and I don't think it would really change. So I don't think it fosters that much of a creative thinking process as compared to, let's say, if you do Olympiad questions. I feel that there's this very stark difference between competition math and school math, in the sense that what kind of questions you can be exposed to. So competition math, what they expose you to, right, is really what we call non-routine problems. And it just means that if I give you an unseen question, right, can you do it on the spot? That kind of thing. And what I like seeing people do is that when they sit there and they just fiddle around for a while, and then eventually they might come up with an answer to this problem. But if you talk about school math, if you see a question, right, you can just immediately write it down. And you don't have to think twice about how to solve this problem. You can just write it down. You see all those keywords, right, and then you just write it down. But that is a bit sad in my opinion. But unfortunately, that's how things are structured, right? And also, I realized that in schools, the beauty of math generally isn't really taught. I mean, I guess that's for my case when I was doing math in Singapore. But I know that in some places around the world, I mean, I'm just saying at least one, because I know that there's this guy on YouTube called Eddie Wu. I think you might have heard of him.
Yeah, 100%, yeah.
So the way Eddie Wu does teaching he's teaching in this school called Cherrybrook Technology High School in Sydney, and I've seen many of his videos since I was in secondary 2, so that was 2017. And I realized that he spends a lot of time developing the intuition to solve problems, which I feel that, well, it can be done in Singapore, but just that generally we don't really have the time to do that, and we just delve into the actual content, and they just throw you a bunch of things and you just go say that, okay, if you see this question, you go do this. If you see that question, you do that. But then Eddie Wu, he just paints you a very, very nice picture of the whole situation and talks about a lot of mathematical history. It's not a plain, boring classroom where you just sit down and that kind of thing where it's just boring. It's not. He doesn't do that. So well, I mean, I don't have the power to change things, right? But but in Singapore, if it were the case where if we spent more time developing students' intuition to solving problems, I think that would be better. And especially now with the role of artificial intelligence in our schools and our societies, right? I mean, I guess to a certain extent, there are some surveys online that say that AI makes you not as smart as before. I mean, to me, I realize that AI does have its dangers, so which is why I try not to rely on it that much. If let's say I'm trying to find something new, then I would rely on it to. I'll ask it for help a lot of times, but I definitely won't copy things wholesale all the time because I have my own style of writing, and I don't want AI to just take over my brain, that kind of thing. So, but in the context of schools, right? Yeah, I guess students maybe they are using a lot more AI nowadays, especially after 2023, 2024-ish. Yeah, if they become too reliant on it, right? And then what's the point of learning math, right? And I don't think they have I don't think students really have the desire to ask AI like, oh, what's the motivation behind this, or how do I like why do I need to solve that kind of thing in that manner, right? I don't think they would, because what they would do is that they would just feed the things into ChatGPT or Gemini, right? And then they just expect an answer, and they just say that just give me the answer, and I don't want to know anything else, perhaps. Yeah. So
I see.
Yeah, a lot of things can be changed, I feel. But it's really like, math, right? Math needs to be taught in a way where you really develop intuition to solve problems. Right. It's not like it's not like a one size fit all kind of thing. Yeah, based on what I have seen in Olympiad math. So yeah, I guess that doing competitions, right, really exposed me to this thing where you really like now I really see it that if you teach math in a way where like how condensed math is taught, right, I guess that's better.
Interesting. So more of like, fostering creativity and, like you said, what the motivation behind doing something rather than just copying the solution and submitting it straight up.
Yes, to me, motivation is is far more important than copying things wholesale. I mean, based on the output given. Yeah, I think that is far more important.
I agree 100%. I definitely agree, because especially when you transition from high school maths to university level maths, that's quite a big jump. So you need to be able to go forward with it and make sure that you perform well as well in your university, because you'll be adapting to a new place. You'll probably be living on your own as well, and you have to balance your academics as well.
Right.
So with all this, you need to be able to make sure that you can stay motivated yourself to keep doing what you love, especially since you're studying pure maths at university. And on that topic, do you think there's a big difference between high school level maths and what you're studying? Because you're studying at NUS, which is one of the world's best, it's a top 10 university in the world. Is there a big difference between what you studied in JC and uni maths, or what's the difference between pure maths and what your A levels?
Okay, so firstly is NUS ranking, right? I think it's the first in Asia, and based on the QS ranking. And if you compare it to the whole world, right, I think it's like 7th or 8th, around there. It's one of the prestigious universities in the world. And I mean, to add on, right, I've met really a lot of really good educators and professors, right? Yeah, that really inspire you in the subject. And yeah, I mean, QS ranking, they base it off research, and I mean, I think it's like primarily research and not that much of teaching, but I've seen a lot of the work that they put out there. It's really, really crazy, and some of them have gone to really prestigious journals. So I mean, that's for one part. Okay, so going back to the question, the difference between junior college math and university level math, if you talk about the generic Singaporean school student, right? What you would do in junior college is something called H2 mathematics. So I'm not sure if you've heard of something like this. So, well, I mean, there's different levels to it, right? So there's H1 mathematics. So I guess H1 mathematics, not that many people take it in the first place. H2 math, I guess maybe like 90 90-something% of the students take H2 math. So you definitely need that compulsory thing to get to somewhere after junior college. So how H2 math works is like, it's the usual kind of thing that is covered in A levels, but there are some differences here and there. I think like in A levels they do mechanics and other random topics like hyperbolic functions and things like that, right? But in H2 math we don't. In fact, mechanics was once in our math syllabus, but then it got removed. So, but then that's the generic population. There are some students who take up an additional subject. So, instead of doing your mandatory subjects, right, your compulsory subjects, like let's say H2 chemistry, there are some students who actually swap H2 chemistry with something else, and that is H2 further mathematics. So H2 further mathematics, what we do is we cover things that are taught in an introductory university level content. So like for instance, not about proof techniques. Proof techniques is something else. So what we cover is like back then we did induction. I mean it's a proof technique, but the more general proof techniques will be covered in something else called H3 mathematics. So I'll talk about it later.
Okay.
Further math, other than induction, we do things like recurrence relations, polar coordinates, further calculus, and what else? Oh, some introduction to linear algebra. It's quite a rigorous. Right. Okay. I mean, like depending on where you go to, because the actual stuff that is taught, the actual stuff that is in the A-level exams, right, for linear algebra is not that difficult. But in schools, they go through way more things. So that is that's the difference. So there's linear algebra. There's like what else? So and then there's the probability theory part, right? So we go through other kinds of discrete and continuous probability distributions and other statistical tests. So in H2 math we do the Z test, but in H2 further mathematics, like if your distribution is unknown or like sample size is small, right? Then sometimes you use a t-test, or there's some other tests out there like the chi-square test and the like Wilcoxon. I think I forgot the actual name, but Wilcoxon tests there are two types.
There are quite a few.
The sign rank. The sign rank and the rank sum test. I can't remember which one it was because back then because of COVID, right? This topic was not tested for A levels, so I didn't really spend that much time studying this, so that was for that. Okay, so that's for H2 further mathematics. As for H3 mathematics, you do some introduction to proof techniques. So induction comes back again, and then you have other proof techniques like contradiction, contraposition, etc. And that's where you really solve non-routine problems. You do calculus again for sure, and you do some inequalities, combinatorics, and I think there are probably some other nuances here and there for H3 math, right? Okay, so you like what I mentioned, the most generic student out there, so the ordinary student who goes into junior college, they just do H2 mathematics, and then perhaps they proceed on to their university life, and let's say you go into a STEM course, right? Or maybe you do something like computer science or some related engineering field, I don't know. Maybe you need some level of math eventually. Or I mean maybe the most common one over here, right, is data science. And the students who go into these kinds of majors, right, after junior college, I realized one thing they have is that one problem they have is they generally struggle with the math content, because it's honestly the huge jump from junior college to university. It comes from the fact that I don't really think it's about maybe it's somewhat the fact that you're too used to solving questions with a fixed set of rules, and then you just the same story over again, that kind of thing. The other thing is, at the university level, you do some things that are actually taught in H2 further math or even H3 math. So people who have done these two subjects in their A levels, right, they do stand an advantage. So like if you do calculus, linear algebra, probability, statistics, stochastic processes, numerical analysis, things like these, right? If you do things like these at the university level, you somewhat have more advantage than your peers, because you do have some exposure to this when you're in junior college. I mean, provided that those few months of break, you maybe like if the guys they do national service, right? Yeah, if you spend time trying to revise these things, you do stand an advantage compared to your peers. But I don't really like the fact that in junior college, right? Yeah, you have a lot of these kinds of cookie cutter questions in H2 math. Like what I said, it's those kinds where you copy paste a solution. Copy paste a solution that can fit somewhere else, that kind of thing. But in H3 math, when I was learning it back then, I realized that the questions can get so creative. And fortunately, I did have some preparation beforehand already. When I was in secondary school, so I would encounter concepts like these. But it's just that every week you meet in class and the difference is that in secondary school I would just read out on my own and not really have a proper mentor to teach me. But then in junior college, when you do H3 math, you do have a teacher. You meet every week, you solve problems, have discussions, etc. That's good. So where was I? Yeah, so it's good that you have all these things in H3 math, and then you go through questions, you go through topics that are like far deeper than what your peers cover back in junior college, right? And then the questions you cover, they are far more intriguing and they're non-routine questions. You can't really apply that cookie cutter technique anymore because you sort of like people say that there's this saying, you must have seen this question before somewhere and have some experience in this. I mean, you can say the same thing about H2 math, but then even for H3 math, right? Okay, for H3 math, even if you have seen a question before, to apply that technique, you still need some skill. It's not something that is totally magic. That's what I'm saying. Yeah. So I guess the difference is really crazy between H2 and H3 math. And the jump from junior college to university, right? Yeah, really there are so many differences out there. And also it's really about the rigor that as to how people are trained in math. So I can just bring up some examples. So calculus, right? Okay, maybe I'll just bring up some examples. So for calculus, there's this thing that is taught in introductory section. So that is the formal definition of a limit, or what they call epsilon delta. So people generally struggle with this because they see a whole lot of quantifiers out there for all that exists, something blah blah, and then they'll be like, wait, so what is going on? But then if you realize, if you draw things out, you apply it to things that are simpler, you have seen before, you realize that the definition actually makes sense. And I think all the more you should be appreciative of what these mathematical concepts teach you, because they are beautiful, and that's what makes them. I think if you really see this at a deeper level, you would appreciate mathematics even more. So that's for calculus. For linear algebra, same thing as well. So we do some proofs. In fact, I was a teaching assistant for 2 semesters at NUS. So I taught this introductory linear algebra course as a tutor, not the main lecturer. So I realized that students, right, generally they have issues proving things, and that's why I developed the intuition to proving things, because in exams you have computational questions and proving questions. I generally don't spend that much time talking about computational questions because it's like the formula is that it's right there. If you want me to explain to you personally, I can, but I don't think it's that nice to take up that much time to I take the dot product of 2 vectors and then you apply Gram-Schmidt, so on and so forth, right? What if I just show you the answers to how Gram-Schmidt, I show you the answers to this Gram-Schmidt process. It's better that way. And it's better if I spend more time teaching you the intuition behind a lot of other proof questions. I feel that time is better spent that way. So, I realized that the jump from JC to university level is really a big difference. The questions you see, the kind of things you do, a lot of things. Yeah.
Okay, so I get from what you say that H3 maths has helped you a lot, in uni.
Yeah, that's true.
Okay, interesting. If you would give advice to yourself, if you could turn back time and if you could go back to GC and give advice to yourself before you entered uni, would there be anything which you would want to say?
Okay, I think it's not really that major of a thing, but back then when I was in junior college, right, I realized that how education is shaped. It's in the way education is shaped is I had this discussion with my friends before. So it's carved out for you. So there's this very neat path from primary school to junior college that is carved out for you. So you just walk on this path, but sadly, right, that path at the end is like, it's somewhat obscure. And that obscure part is when university comes, because at university level, if you realize that if you make some mistake, right, you kind of like at a dead end. But then when you're at junior college, you make a mistake, you realize that at the end of the day, you can still come back. You can still pull through, because the end goal is A levels. I mean, like O levels is the end goal for secondary school, right? But for university level, your end goal is like what? Because different people have different kinds of end goals at the end of the day, right? So maybe if you want to start a family, or start a family, get a degree, have a house, etc., right? A lot of these kinds of goals that people can have. It can be a mix and match of different things. My point is that in junior college, we generally have this idea that, you just take your A levels, you do well, get a scholarship, go into university, do well, get a job, and that's it, right? But then it's like there are a lot of question marks throughout this on this path itself. There are a lot of question marks. So you'll be wondering, so I'll be wondering, right, if I could turn back time to go back to junior college, what would I tell myself? I should just tell myself that, hey, there are actually other opportunities out there in the world. You shouldn't just stick into academia. So back then, I was so obsessed with, let's say, I was so interested in further math, history math, and so on, right? And Olympiad. Then why not I just go to uni, I do pure math, and just spend so much time on it. And eventually you publish papers and get tenure and so on, right? And you become a professor that the world knows you for your work in some groundbreaking area, probably some undiscovered area of math, who knows? Yeah, it can be that sort of thing, and that is the ambition that some of us might have, right? Some crazy thing that perhaps could only be applied to the case where you're like Terence Tao or something like that. It's like the exceptional case, but too bad. I don't think that many people are that exceptional case. So if I could tell myself back in junior college, right, you shouldn't really spend that much time delving into one thing, but you should branch out into thinking about other aspects of life. So I should think about family, as in eventually starting a family. That's one thing, and the other thing is perhaps career aspirations. You shouldn't just stick to one thing, because there are many other things out there for you to try. So I guess it's a pretty short answer, but yeah, that's all I have to say.
Okay, no, I mean, fair enough as well, because you were pretty interested in mathematics, and now you think that in JC you could sort of maybe look at other things, discover a bit more when you had the time to, right?
Yeah, discovery in the sense that I shouldn't just look at just solving math problems for this for school, right? But I should look at what else can I do with math other than this academia kind of thing, so that you can have earlier preparations.
Okay, I see. Thank you. Extremely good advice, and fair enough. I understand what you say as well. One last question for you before we end this interview. Finish this sentence. So I'll give you 2 blanks.
I thought there are some other questions about like Math Society and OEIS, that kind of thing.
Okay. We can continue with those. Do you have a little bit of extra time now?
I have a lot of time. Actually, I have a few more hours to spare, actually.
Oh, okay, sure. Yeah. Then we can go ahead. So yeah, as you said, about your OEIS. So you've contributed to sequences to the OEIS as an undergraduate. So what was that experience like, and what does it feel like knowing that your work is being used by mathematicians worldwide? And if you could just introduce to our viewers what the OEIS is.
Okay, so let me just go to my CV. That's where I save all my things. Okay, so currently I'm on my CV, and I'm looking at the contributions. I have one section where I talk about the contributions to the OEIS. So the OEIS, it is the online encyclopedia of integer sequences. So I think it was set up by 2 guys. So or maybe it's like one person. Maybe this guy called Neil Sloane. Yeah. So that was a pretty long time ago. some history, right? I'm looking at the Wikipedia page. So 1965, he began collecting integer sequences on file cards, which were later transferred to computer punch cards. And then later on as the years went by, right, OEIS became an online website where people could publish sequences. And how it works is that you need to create an account and then you just publish a sequence, right? And then there'll be a lot of people in the community that will talk to you about it. Talk to you about it in the sense that maybe they do some edits and you have to wait for a while before I think Sloane would actually publish it for you. Maybe there might be some other guy who can publish, but based on my experience so far, Neil Sloane has been the only guy who has been publishing all my sequences. So and the good thing, right, is that let's say if you want to search up a sequence. So right now I just keyed in the sequence 1491625. As you know, these are the square numbers. If I just key into OEIS, right, what I would get is they tell me that most likely you are talking about this sequence. They display 207 results over here, but then in order of relevance, right, most likely you are searching the one where it is A000290, so that is the sequence of square numbers. And they tell you a lot of things, like the comments. So for instance, right, one of the comments says that any square number is the sum of two consecutive triangular numbers. So I didn't know this fact. And then they tell you a lot of other things. So like some of the references, formulas, etc. It's really, really long. It's a really good online repository of things. So I use this a lot, and it has helped me in some of my research. When I publish things on, when I put up my preprints on archive, or some of them when I publish. So what have I contributed to the OEIS? So I think the contributions mainly started early this year in January. In fact, on my CV, I mentioned that I had 2 contributions in Jan, 1 contribution in Feb, 1 in April, and 1 in May. And currently, I have 3 other edits pending by the editors of the OEIS. So that is still in progress. So let me just say one of the examples that I've contributed. So there is this sequence A392834, and this is a joint work with a friend called Gerard. And what this sequence says is it's a pretty long description. It is the time taken to get n people from one side of a bridge to the other, where A, the only flashlight must be carried when crossing, B, at most 3 people may cross at the same time, C, a group crosses at the speed of the slowest member, and D, the kth person requires k seconds to cross the bridge. So we developed this sequence of numbers as part of a research project that we did together. So as mentioned, it's a joint with my friend Gerard. So talking about how perhaps some of the sequences might be used. So far I haven't seen people using some of my contributions. So far I only made 3 contributions. Then the other two contributions that are published, they are part of, there are some comments regarding a sequence. So it's not saying that I contributed a new sequence to OEIS. But as for the sequences that I contributed to the OEIS, so far I don't think anyone has made use of it, but perhaps in the near future we might see some new things. Because you got to think about it, OEIS has hundreds of thousands of sequences. The whole world, there are so many things out there, right? So I guess we might have to wait for certain things.
Okay. So it's basically like a collection of all the different types of sequences which people can think of.
Yes, but obviously you need to think of meaningful ones. So if you think of a random sequence of numbers, right? Let's say I could give you some random sequence 1, 104, 264, 201, 219,000. This sequence of numbers doesn't make sense, right? And if let's say there was really some meaning to it, then sure, you can go publish it in the OEIS, but you need to state the significance and some of the examples in which this kind of thing pops up.
Okay. Interesting. And did you do this while you were studying in NUS in your first year?
I actually did this in the second semester of my second year.
Oh, okay.
Mm.
Okay. So it was pretty recent then.
Yeah, so at that period of time, I was spending a lot of time trying to think of, okay, what can I put out there, so that maybe some people might use it. And I also
Mm.
I was so invested in the sense that surely there must be something that I have that some people haven't thought of. And yeah, sure, it did. I did publish some sequences out there.
Okay, interesting. And while you were at NUS as well, I've read that you were the president of the NUS Math Society. So could you talk a little bit about, what activities did you do, and what was probably the biggest taking that you learned from being the president?
Okay, so when I was in the NUS Math Society, so it started out when I was a freshman, so first year of undergrad. I started out as a project director in my first year. The second year, I became the president. So to give some background context, when I was project director, I actually did a lot of things alongside my other project director friend. So his name is Ryan, and together we secured speakers for talks and organized contests like Sudoku. Then there's this other problem-solving contest, like mainly about Olympiad math and uni kind of stuff. It's called Problematic. So yeah, we did a lot of crazy things together when I was a project director. And when I became the president of the Math Society, I realized that the role of a project director and the role of a president, they are very, very different. As in, as a project director, you are doing a lot of the things that at the bottom, so planning things like that, right? And to some extent, I really enjoy doing those kinds of things because I really love math. Yeah, but as the president of the society, you actually spend way less time doing this kind of thing, because what you spend time doing is managing the different departments so that we have like one workshops group. We have people in charge of logistics, people in charge of projects as well. So that was what I did last time. And then we did way more things in my second year than when I was in them during my first year. But I realized that being president, it really taught me a lot of things, in the sense that, so it is true that, okay, so firstly it's true that you spend less time doing things, but you spend more time telling people what to do. So yeah, that's one thing. And the other thing is that, you get to see you really get a lot of opportunities out there. So because our role as the society, right, is that we are connected with the NUS Department of Mathematics, and also the governing body of the mathematical community in Singapore. So that is the Singapore Mathematical Society. So we do have some opportunities from these two areas, so from the department and from the Singapore Math Society. Sometimes it's like, let's say they need help in like for student volunteers to do something, right? Or student ushers, or maybe some things that we can attend and listen to. Yeah, so these are some of the opportunities out there. In fact, when I was during my freshman year, I remember that I got invited to I think it was like the science, so NUS Faculty of Science dinner, anniversary dinner, right? But I can't remember how many years it was. Maybe it's like 120 or something like that. I can't remember the exact number of years. Yeah, but we went to some place. So I got invited as part of the Math Society to attend this dinner. So it's a good opportunity. Then as president, the good thing is that we collaborated with other student societies in NUS. So like there's this Physics Society, Statistics and Data Science Society, and yeah, we had some collaborations with those. And I think the biggest takeaway that when I was president, right, was that I actually had the chance to go to the United Kingdom for a trip for the there's this thing called the UK University Integration Bee, and that how it was. So apparently the organizer, I knew him before this contest, so he's my friend. His name is Vishal, and apparently I think he has been hosting this contest since I think 2022 or something like that. I can't remember the exact year, but it's somewhere in the 2020s. So initially what it started off was a competition between the UK universities like Oxford, Cambridge, Imperial, Durham, right? So I think some of these and maybe others. Then eventually Vishal, he decided that he expanded it to Singapore, because I think he came to Singapore for some research some research internship or something like that. So that was 2024, and then he reached out to NUS and NTU, and so that's how it started. That's how NUS got involved in this competition. So for this competition, the first 2 rounds are held in NUS. In fact, the second round is when the NTU and NUS teams come together to compete. Whereas in the final round is where the students, like the top performing students, they get invited to the UK to participate in the final round. So I guess that's the nice thing about being president. So yeah, you really get to see a lot of things, get exposed. Yeah, you really get exposed to a lot of things and have many opportunities.
Interesting. So, the project director. When were you project director? May I ask? Do you remember the year?
August 2024 until May 2025, around there.
2024. So 2 years ago. Okay. And was that during your first or second year at uni?
First year. First year was project director.
Wow. Okay, that's pretty cool. That's nice. And as a first year student as well, you were part of you were the project director. You were new to uni, you had to focus on your academics. You said that you were a teaching assistant as well, leadership. Did you ever burn out? Or how did you balance all of these things?
Okay, so I think so firstly, right, burnout is a phrase that initially I didn't believe that it was true. And I think that in my whole life, I guess I only experienced burnout once. So I guess some people, they experience it more than once, right? But my experience was pretty unexpected. So firstly, right, how I test for burnout is as follows. If let's say I'm tired, and I'll just find some place to sleep. So thankfully I have my bed next to me, right? But if I'm in school, right, there are only like maybe 1 or 2 places to really sleep. So like one place is the department lounge. That's where I usually sleep, on the sofa. In the past, I went to this place called Pit Stop. So they had massage chairs and things like that. So I would just sleep for maybe 1 or 2 hours and just relax there. But I really don't like putting my head down on the table and just doing that kind of thing. It actually makes me uncomfortable. But yeah, so sleeping, right, helps. And sleeping is the way to test whether I have a burnout. So what I mean, if let's say I'm studying very hard for something, right, and if I'm tired, and I can't look at the screen anymore because that would make me worse, right? So I'll just go for a nap. So the moment I wake up, if I have motivation to look back at my, like usually it's I think like math stuff, right? If I have motivation to look at my math stuff again, then it's not burnout for sure. So it just means that you're really just tired. Yeah. And in fact, this was quite common for me back in secondary school. So in secondary school, sometimes when I go home, I'll just sleep on the sofa, and when I wake up, right, I'll just do my work and maybe read a bit of math, but I didn't really have time to do that. But yeah, I don't think that was burnout. So even in university, right, I don't think burnout was that common. I think it really only happened once. So the situation was as follows. This was my special term of my first year. So special term just means your summer break.
Okay.
Yeah, so the summer break was from May to August 2025. What happened was that I actually had this undergraduate research project as part of the UROPS thing that we have in NUS. So UROPS just stands for Undergraduate Research Opportunities Program in Science. And I did this research project with a professor at NUS. And over the span of these 3 months, right, I realized that, firstly, the papers that I had to analyze were really, really difficult. And I relied on a lot of AI for help. Back then, it wasn't really that good in helping me understand all these research level stuff. I think it was more suited for maybe elementary content in university. But I had a lot of difficulty trying to get things done, right? Sometimes I asked my professor for advice and things like that. And there were times where I was doing the report, I was okay. But I remember that maybe there was like 1 or 2 times where when I was doing this, writing up the report for this, right, that I was tired, so I slept. And when I woke up again, I saw this, I was like, oh, I'm not going to look at this. So it's not made me feel avoidance of this issue, So I guess that was the only situation in my life that I had a burnout. So if I just study like general mathematics, right? If let's say I study, so right in front of me, right, I have my bookshelf, right over there as well. I can just take up a random math book, right? I can just read it for very long, and I'll enjoy it. It's nice, but the problem is that if I look back at what happened to me when I was doing that research project, that is burnout. Yeah. So, burnout in the sense that I don't want to look at any other things. I just want to like get this done and over with, and then I can just sleep forever. Yeah, maybe that kind of thing. Yeah. How I manage my time, I think it's something you asked for other areas, right? So, firstly is I think a lot of people know this about me. I'm a person of efficiency. So, if let's say I have some task, I would try to get all the things done as soon as possible. So, like for instance, right, in NUS, I'm part of this. Okay, so not exactly a community or committee or something like that, right? But I have to take photos. Okay, I have to take photos for different events. So I think it's like mainly open house, and that is so we have 2 open houses, right? One is in March and one is in May. And I remember that after we take the photos, then my the person who assigned me this role, right, he would just tell me that okay, maybe you have about 4 to 5 days to edit and then eventually submit the photos. But then what I would do is that I would just do things pretty quickly, and of course I would just inspect everything, right? I would do this task very quickly, and I think on the nights of the event, right? So the event is like 8 a.m. until 5 or 6 p.m. So I think at night is when I submit everything to him, and I just don't want things to get done at the very last minute, because I have this feeling that what if let's say there's something that needs to be done after let's say after you edit the pictures, then something needs to be done, right? At least he still has some time to tell you what to do. So if you submit it early, then it'll be nice. I don't like it for it to be the case where you submit it maybe 1 hour before the deadline. I mean, there's some people, they post on Instagram Reels, right, saying that they submit some assignments 2 minutes or even 1 minute before the closing time on the platform, right? And then I don't think this is a nice thing to brag about anyway, because it just shows you that your time management skills is really bad. So I guess with my proper time management skills from my primary school days, right? Even though primary school I suffered from gaming addiction, I mean, but I could control it. I still spend a lot of time trying to work things out with a lot of my academic subjects, and even in secondary school as well. I think secondary school was the real test of doing a lot of things, because I had a leadership position, competitions, my academic studies, a lot of things I went through back then. But having proper time management skills, right, that is really essential. So okay, like even for myself, right, I actually don't. Funny thing is that I don't have a to-do list back then. I didn't have a to-do list. So back then I sort of knew what I needed to do at the back of my mind, because sometimes at some random point of the day I'll just think of, okay, I need to do this by this time, and so on and so forth, right? But I think now in university, because you don't go to classes, you don't go to fixed classroom daily, and you don't have the same set of friends here and there, right? What I have now is a calendar. So I use Google Calendar, and I just put in a lot of my stuff in, and I just check that, oh, okay, I have this event coming up. Then I have to make sure that, have I done everything already, etc. And even for my linear algebra tutorial, so for the previous semester in semester 2, I taught every Monday from 10 a.m. I think it's like 10 a.m. No, is it 10 a.m. to 12 or 11 a.m. to 1 p.m.? I can't remember, but it's 2 1-hour slots. And think about it, it's a Monday class, and definitely you need to make a lot of preparation beforehand over the weekend or something like that, right? But yeah, generally I wouldn't make use of the weekend to do this kind of thing. I would just rush a lot of things on the weekday and over the weekday, and just get it done and sorted really quickly. And to a lot of people's surprise, right, I even had the time to vet my student solutions before the class. So although there'll only be that same handful of students who would come up to you and ask questions, right, but I did have the time to reply to students' queries here and there. So I really guess that being busy, like when people claim that they are busy, I think it's just fake most of the time. It's just a matter of how you manage your time.
I see. Okay, so like you said, time management, discipline was taught to you since you were in primary school, yeah?
Yeah, I think that's really important. It's a really important trait.
Okay, and as you said, you're going to EPFL, which is in Switzerland,
Yes.
and you're bringing all of these experiences and all of these skills along with you there. What's the most exciting thing about studying in Switzerland, studying maths, especially within Europe?
So studying in Switzerland, okay, so first thing is that I heard Switzerland is very expensive, but I don't think everything there is that expensive though. I gotta see it for myself. So I guess it'll be a very, very interesting experience because firstly, the first time I stepped out of Asia was when I went to UK. That was in March. So in fact, I went to 3 different cities in the UK. So that was London, Cambridge, and Canterbury. And I guess because I've always been interested in Europe since young, especially like UK, right? I knew about things like British monarchs and things like that. Completely random fact, right? But yeah, so I was really interested in Europe back then, and even until now. So I think it makes me more excited that hey, I'm going to Europe for exchange. So all the more I should be looking forward to this, right? Yeah, and even in EPFL, they have a really nice. I heard they have really good math faculty there. I think it's the only place in the world where, like, the only university where they have 2 Fields medalists. So one is Martin Harrer and the other one is Marina Wiazowska. I'm more familiar with Wiazowska's work because she was known for proving the sphere packing problem in 8 dimensions. Yeah, so, and I think they have some other influential math figures over there. I mean, not just Fields medalists. Yeah. I'm really looking forward to this, having a different life there, and interacting with the math community as well. Because I really want to see how the Europeans treat mathematics. And I heard that they had some accelerated learning as compared to Singapore. So for the European side, apparently they study a bit of calculus, calculus and linear algebra, and a bit of discrete mathematics when they were in high school. I think there's like France and Germany. I think that's the case. That's why when they go on to university, generally they start off with something like real analysis. So this was a fact that I heard from one of my seniors in NUS who actually went to Heidelberg, that's in Germany, for exchange.
Okay, interesting. No, as you said, Europe's pretty famous for mathematics. Many mathematicians were Europeans as well, especially in the olden times. Euler, Euclid, Archimedes, a lot of them were European.
Right.
Okay, interesting. But then, all of these people, I'd say, they were more into the academic side. And a lot of the general public think that if you go to study pure maths, that means you have to go into like research or teaching or something like that. Could you maybe shine some light on what are the other career prospects for a pure math student, if there are any other?
Okay, so there is this misconception that if you do pure math, then chances are you end up as a research mathematician, right?
Right.
Or maybe you end up as a high school teacher or something like that. But that is not the case. Unfortunately, I do not have that much information to share, but I can just share whatever I know from what I heard. So firstly, if you're a pure math person, maybe you get a bachelor's degree or even a PhD, right? It's not like 20-ish years ago, right, where not many people went to university, and that it's like in this modern day and age, right, it's harder to find a tenure position around the world. That's what I heard from my professors. Especially if you're working in some very, how do you say, like not really classic areas of math, then it's really difficult to get a tenure position anywhere around the world. So, and also there's this thing where like let's say if you did your bachelor's degree in NUS, and if suppose you want to get hired by NUS one day, then you you must be okay. It must be the case where you get your PhD from somewhere around the world, but not Singapore, because they want some overseas experience, right? I mean, you can't just be learning the techniques from your own professors. You need techniques. You need to learn some other things from other influential mathematical figures around the world, right? So that's what I think that's a valid reason. But then, as a pure mathematician, right, other than going into academia, there is this general saying that people go into quant, right? Other than that, you can go into finance, investments, right, like risk stuff. I'm not exactly familiar with those sorts of things, but the thing is that in industry, that's where the money is, and that's where they look up for math people. And this is where I quote some other people that I know who told me this, and that many math people, they have sold themselves to the industry, right? I mean, I think it's a good thing anyway, because they need people who are fast and who are critical thinkers. And really, it's where learning math actually teaches you how to think critically. And in fact, for something like quant, so quant just means like there's I think like two different main roles. One is the quantitative trader, so you work behind the desk and then you just trade during the various hours, right? The other one is being a quantitative researcher, so that's where you develop algorithms to, I don't know what exactly, but yeah, so you develop algorithms for a company. But yeah, so the thing is that, in fact, recently I got accepted into Optiverse as this program. It's called Future Focus program. It's in Singapore, so it's a 5-day program where I'm really excited to go look at what is there out there for me as in this program, right? Yeah, because recently I've been involved in some other event. So previously Optiver invited me to this other things like, wait, what's the actual name called? Let me go find it out. I can't find it, but it's like something like a discovery day kind of thing, where you just spend the whole afternoon at the office, right, and try to understand what goes on, right, and they give you some brief introduction to quantitative trading. But this 5-day program, I heard, is somewhat different. And in fact, the recruiter, she told me in the interview that when you go out of this program, you learn way more things than you expect. So I'm looking forward to that. So job prospects wise for math people, right? Apparently, if you go to any website in university, like let's say NUS Math, right, they'll tell you that there are a lot of opportunities out there other than being a teacher or a researcher. But it's just that, I've never gone to a career fair to look at what is out there for us, right? So unfortunately, my vision, my perspective on this matter is not that deep.
Okay, I see. But no, anyways, thank you for sharing your information. Yeah, I've heard quant is a pretty big up and coming field as well, and it involves a lot. It combines, I think, computer science as well, right? Since you said a little bit of algorithms involved.
I guess it requires some computer science knowledge for sure. But I think the level of
it's primarily maths in that sense.
I think the main emphasis on math is really elementary probability and statistics. You don't, based on what I heard from there's this quant researcher that I met at Optiver, right? Yeah, so he said that you don't need hardcore level math to understand all these things, right? It's really a lot of intuition based on what I heard.
Okay. Interesting. Good to know. Yeah, I also know a lot of friends. I have one senior who's actually coming to NUS to study quant finance. So it's exactly.
I mean, actually, to talk something a bit about quant finance as a major, right? I feel that it's somewhat I have somewhat of a skewed perspective, because the stuff that you learn in quant finance, I've ever seen it. It's, how do you say? If you want to become a trader, I might be wrong, but I think I have had some discussions with friends, but the kind of thing that you learn as a quant finance major is not that relevant to being a quant trader.
I see.
Yeah. it's more of like if you do something like math or computer science that is relevant. But well, different people have different opinions. Yeah. So this is what I think. This is what I personally think based on some of the discussions I had with my friends.
Okay. And if, like, in an alternate universe, if you wouldn't be pursuing pure maths, what else do you think would interest you, which you would take up at uni?
Oh, actually, this is a very nice question. I ever thought about this, like what I would do other than mathematics, right? Okay, but it's a very very strange thing to say, but not many people know this about me. So firstly, right, if we trace back to my junior college days, so during my junior college days, I did various subjects, right? Instead of doing chemistry, I did further math. Instead of economics, I did geography. And fun fact is that if you compare, so a lot of people might think that I love physics, right? Okay, actually I do love physics, but I enjoy geography much more. So like since young, I always loved geography, right? Like, you know, I would go look at the map and look at random countries around the world, and you just say that, oh, if I have this country, then what's the capital, right? Or if I have the capital, then what's the country? And I'll go memorize things like like the simple things like list the continents and oceans of the world, and some of the various some of the landscapes, right? And tourist destinations around the world. Yeah, so if I give you a picture, then could you tell me where it is? Yeah, okay, but I'm not GeoGuessr. Like, I'm not like a GeoGuessr expert where, how do you say? Like, if you give the location, right? I mean, sorry, if you give a picture, then you can pinpoint the exact location. I'm not that kind of guy. Although I played GeoGuessr, which I'll tell you about it in a moment. So, my interest in geography, it was kind of like a random thing, you know, because when I was in primary school, right, my mother, she would always buy some random encyclopedias, right? So, you know, in primary school, you would have this kind of like a silent reading session, and you were forced to bring a book, right?
Yeah.
So sometimes I would just bring this encyclopedia, and I just read random sections of it, and I get so interested because there are a lot of colors and a lot of random facts, and I'm the kind of guy who likes trivia. So, and I realized that I'm really interested in a lot of these geographical concepts, and especially things related to human geography, especially tourism. So, move on to secondary school, I loved geography. Move on to junior college, I took geography as a subject as well. And I think when I was in junior college, that was the period when GeoGuessr was pretty hyped up. So I remember I played the Singapore map, and I tried to challenge myself to, let's say, 20 seconds per location. And I always got really, really high scores. So I think out of 25,000, generally I can hit like 23,000 or 24,000. So that is almost being perfect, right? Yeah, so I like doing this kind of things back then. Alright, so let's say if I were to turn back time, I would be a student majoring in geography. But it's just the fact that I'm not sure as a geography major, right, what kind of prospects there will be for me out there. Maybe something like in the public sector. I'm not exactly sure because I never researched into what you can do with a geography degree, right? But I'm really interested in urban landscapes, tourism, these sorts of things. That's why I got so interested in looking at landscapes, right? And in fact, I'm a photographer, and I'm really, really interested in photographing landscape pictures.
Wow, that's pretty unexpected. You know, maths and geography are kind of like on two opposite ends.
Right. So geography is like a different end to it, right? Like math and geography are different ends of the spectrum, but somehow I do have interest in something like geography, right? That is what makes a lot of people unexpected.
Pretty cool. So, you know, as you said before, some advice. Sort of look at things in a different way. Like you said, look at maths at not just academia. It's interesting, you know, geography, and I feel like being exposed to different subjects in high school, you can find many different interests of yourself, not just, you know, picking one and sort of going with that for the rest. It's good to have other interests as well.
That's true, but I feel that it's important to like, one thing I realized in life is that you shouldn't follow your friends fully. So what I mean is that, alright, you shouldn't follow the general crowd, unless it's a really good thing. So why I say that is because in junior college, the general subject combination would generally force people to do chemistry and economics, but I didn't do any of those because I realized that chemistry in junior college, although they say that there's this saying that chemistry unlocks many doors in university, that is true, but it's not applicable to me because I don't need chemistry in university, right? Like when I'm doing real analysis, I don't need to be doing titration at all. That doesn't make sense. Right. Unless you can find some correspondence between the two, then sure, you might get a fuse medal. I don't know. So you don't need to learn how to do titration in real analysis. So why bother doing chemistry? So that's why my knowledge of chemistry is stopped right there. And as for economics, for some reason I couldn't get used to all these diagrams, right? So and I always loved geography, so I was thinking that hey, why not just pursue this in junior college? So I did 2 subjects that I think 90+% of junior college students would do. So if you think about it by inclusion-exclusion principle, what's the probability that you find someone who doesn't do these subjects? It's very, very low, right?
Yeah.
And then you put on further math and history math, the probability gets even lower, right?
Yeah.
So it's really about, I think back in junior college, right, it was really a phase where you pick your interests, and luckily I had things in mind, right, that I really love, and I just pursued them further. And I think my teachers could see that as well. Like, you see a guy doing geography, right, because he loves it. Just it's a good thing.
Interesting. An interesting take on life as well. I appreciate that you gave this advice to us. We're sort of approaching the end of the interview. Just a few more questions to end up. By seeing, how students are in the modern era, like how they think, especially in high school students, what advice would you give them for them to be able to thrive within high school and as well as pick the right course for their university?
Wait, can I not answer this because I don't know what to say?
Okay. All good. It's okay. Maybe you can move to another question. If a 16-year-old or like a high school student, maybe JC, Sec 4, Sec 3, they would tell you that, they dreamt of becoming a mathematician, what advice would you give them?
So I guess for this thing, it's a far easier question to answer. I would say that it's good to have that kind of ambition when you're young, but then you got to realize that what is there out there for you, right? So as a mathematician, as a 16-year-old, that's very, very young, and it's good that you have that kind of ambition to become a mathematician, for sure, no doubt. But you got to realize what you know as a 16-year-old, is it sufficient to really plunge into the deep waters of math? Yeah, so that's one thing you got to ask yourself first, because as a mathematician, I realized that as a 22-year-old right now, I realized that there are so many things in math out there. It's so broad. You have algebra, analysis, logic, graph theory, even theoretical computer science is part of it, I guess. There's so many branches of math, right? Even someone working in pure algebra might not understand what someone is working in purely analysis. I mean, I don't know what purely analysis even entails, but you do get the point. It's math, but branches of math, but then people don't understand each other. And even I have ever come across that people who are working in the same field in math, they might not understand each other as well. So, because perhaps they're working in specific areas. My point is this: if let's say you really want to become a mathematician, you realize that if you want to really plunge into math and have some nice research area later on, the truth is that math is all these sub-branches of math. They are so broad. How do you figure out what you want at a young age? You need some exposure to, you somewhat need some exposure to all these higher level contents. Talk to people, math professors, right? And all these researchers. They are the ones who can really tell you and really guide you through. But I still feel that as a 16-year-old, it's quite difficult to say what you actually like. Because my interest in math, it's honestly somewhat like in analytic number theory, modular forms, zeta function, that kind of thing. I don't think I would go anywhere else. I don't see that, honestly. Like, I can't see myself working in something like purely combinatorics. I don't think so. yeah, maybe I could delve into a bit of like representation theory like that in the future. But that still has some links to whatever I've been doing in the past, because like partitions and representation theory, right? There are some links, but I'm saying that I'm not going to somewhere that is very far, like combinatorics or something like that. No. So if you do have some interest, then continue reading up. Okay, read up. Maybe you can pick up an undergraduate text or something like that. There are many accessible undergraduate texts out there, and not just that, videos. Videos are a good way to learn things. If you were to compare it during my time as a primary school or secondary school student, we didn't have that many resources on YouTube, like many good resources on YouTube. In fact, like 3 Blue 1 Brown, it started only around there. But then right now, he has made so many nice videos on the internet. Numberphile has progressed as well. You even have like videos where there are AI voiceovers, but I don't watch them anyway. But you have many other crazy good channels on YouTube that you can learn a thing or two from them, so that you know that, hey, maybe it's really becoming a research mathematician the way to go. Yeah, you can question yourself from that. And then also you might bump into professors one day, go attend talks, public lectures, things like this, and yeah, you can really find out for yourself.
Okay, interesting. Thank you for the advice. And no, 100% I agree with the advent of AI as well. You can learn anything from AI. Like, I'll give you an example from my own experience. So I'm studying Cambridge levels. I've done further maths as well, and there was one chapter about linear algebra. It was a really new topic to me. I hadn't learned matrices before that. Eigenvalues, eigenvectors, characteristic equations. This sort of stuff is very new, and with AI being there, it really helped me. So I think, as you said, students should make full use of all the resources that they have right now.
Right, and not just resources, but having a nice mentor, because finding a mentor is really difficult, right? Someone who can listen to you and guide you through your mathematical journey, that is hard.
Okay, right. It 100%. It helps if you have someone who's experienced, who can guide you, who can fix any of your mistakes along the way as well. Okay, perfect. Now, to finish off the interview, one last question. If you could leave every student watching this with one piece of advice about anything at all, about your outlook on life, maths, balancing everything, all of your work, anything at all, what would you give? What's the one piece of advice you would share to the world?
So the one piece of advice, I think I kind of got influenced by the impact of COVID. So it's something that is surprisingly not about math, whatever I'm going to tell you, but it's about trying to really go experience and see the world out there. That is my advice. So like, why I thought of this is because after COVID subsided, right? So that was like early 2023-ish. I actually did my first solo trip to China. That was in June. So I left Singapore on 15 June 2023. I think it's a Thursday. Yeah. So I guess you should, like these students, right? And advice is that go and see the world out there. There are a lot of things out there to see. Not just China. China is a very big country, right? A lot of things to see, a lot of nice landscapes and food and heritage, right? But go see the world. When I went to Europe recently, right, I saw that, wow, it's like seeing Big Ben in person, seeing Trinity College in Cambridge for the first time, doing punting, like what was in the movie. I don't know if you know Theory of Everything, right? When they had Stephen Hawking. Yeah. So things like this, or even the Man Who Knew Infinity, the movie, right, starring Ramanujan. So I went to Trinity College, went to all the different sites that were filmed in the movie. Yeah, if you see these things in person, right, it makes you feel different. Yeah. So visiting China was one of the goals I had back then. I went to Korea as well, and it's mainly China that I've been traveling to because I really love the landscapes and food over there. And also, one particular city that I love is Shenzhen in China. So another city around the world that I like is Dubai. I really love the city, all the metropolitan vibes. Although I know that some people they prefer something that is more rural. Yeah.
Right.
But then in due course, I do have some places that I want to visit around the world. But I mean, if I talk about exchange, so when I go for my summer, okay, more like my fall exchange, right? Where my girlfriend will be visiting me in due course when I'm over there in Switzerland. But we're going to travel to some countries in Europe. So yeah, I do have some ideas planned out already, like let's say Iceland, Sweden, Netherlands, etc., Italy, and so on. So things like this. And also another place that I've been wanting to visit is actually Los Angeles in the United States. So, well, I guess if you ask a guy why he wants to visit LA, right? Chances are you might know why, and it's because they grew up playing GTA 5.
Yeah.
So so GTA 5 was like a lot of the scenes, right? They are based off Los Angeles, so I've always been wanting to visit there. Yeah. So yeah, really go see the world, travel. There are a lot of things to see out there. Yeah.
Okay.
That's my advice.
Excellent. Thank you so much, Pang Ern. I've been wanting to speak to you for a long time, especially as I've seen you work in maths. I've heard about your work from other places. As I said as well, thank you so much for helping me, getting me introduced to IYMC. It's been a big change.
Sure.
It's amazing learning about maths as well. I hope we can definitely keep in touch. And thank you so much for your time for today's interview.
Sure.